Let's solve the system of equations negative 16x minus 8y equals 24 and 4x minus 8y equals negative 56. Okay, I have a variety of methods that I could use to solve this system of equations. I'm going to use the substitution method. Okay, so to use the substitution method, you have to decide which of these four variables is the easiest one to get by itself. I'm going to focus on this one right here because it is part of a positive variable term. Okay, this is a negative variable term, a negative variable term, a negative variable term. This is the only positive one. That's my reasoning for it. It looks like it's the easiest one because of that. I won't really know until I start working it out. But okay, I'm going to take 4x minus 8y equals negative 56 and get x by itself. Okay, if I'm trying to get x by itself, I need to remove all terms that have nothing to do with that x that's on the left side. Okay, so that would be this negative 8y term. I will get rid of it by adding 8y. And by get rid of it, I mean I'm moving it from the left side to the right side, so that way it's no longer near my variable term. Okay, adding 8y to both sides, I'm left with 4x on the left side. The right side is now 8y minus 56, or negative 56 plus 8y. I like to put the variable term first. Okay, divide every term by 4. 4s would divide out. I'm left with x equals 2y minus 14. Okay, so x equals 2y minus 14. This is a rewriting of the second equation here. So I'm going to actually rewrite my system of equations where the second one now has been rewritten. The relationship between x and y is still preserved with this equation here as it is here. It's just in a different form. Okay, so now the second equation here is saying that x is the same thing as 2y minus 14. X is the same thing as 2y minus 14. So what I can do with that is take my first equation here, the one that has not been rewritten, and I can rewrite it, but instead of an x, I'm going to put in 2y minus 14. After all, we have decided that that is the same thing as x. Okay, well then we're in good shape. Because now I have one equation with only one variable, y. Okay, so let's work it out. Negative 16 times 2y is negative 32y. Negative 16 times negative 14 is positive 224. Minus 8y equals 24. Bring all that down. Okay. On the left side of this equal sign, I have some like terms. This negative 32y and this negative 8y, I can put those together. Negative 32 minus 8 is negative 40. So we have negative 40y plus 224 equals 24. Okay, so now let's get rid of the constant term on the left side. Subtract 224. I don't want any constant terms on my left side. That leaves me with negative 40y equals 24 minus 224 is negative 200. Get y by itself, divide both sides by negative 40. Y equals negative 200 divided by negative 40, which would be 5. So we have our y value is 5. So how do we find the x value? Well, substitute in this 5 into any of your equations. You can plug in 5 for y here, you can plug it in here, you can plug it in here. This one's usually the easiest one to use because you already have x by itself. So you won't have to solve the equation once you plug it in. Okay, so let's plug it in. X equals 2 times 5 minus 14. 2 times 5 is 10. 10 minus 14 is negative 4. So there we go. Negative 4 comma 5 is the solution to this system of equations. Okay, the next part of this question asks us to determine if the lines are parallel, perpendicular, or neither. Now, I haven't done anything as far as rearranging it and looking at their slopes to determine whether or not it's parallel or perpendicular. I haven't figured that out yet, but I know it's not parallel because parallel lines do not intersect. And here, here we have an intersecting point. So I know it's not parallel. It might be perpendicular, it might be neither. So we'll go and figure that out. I'm going to rewrite each equation, rearrange them, get y by themselves, so that way I can look at their slopes. Okay, so negative 16x minus 8y equals 24. Negative 16x minus 8y equals 24. And I think it is 4x minus 8y equals negative 56. Let me double check that. Yes, okay. So there are my two equations. Let's get y by itself for both of them. Okay, so starting on this one here, if I want y by itself, I need to get rid of this variable term on the left side first. There are two variable terms, right, on the left side, but I don't want to have the x variable term on that side. That needs to be on the other side. So I'm going to add 16x to both sides. Negative 8y equals, these are not like terms, of course, so I'll just put 16x here, and it's a positive 24, so I'll do plus 24. Then I'll divide everything by negative 8 to finish getting y by itself. And that will leave me with 16 divided by negative 8 is negative 2, so that's negative 2x. And 24 divided by negative 8 is negative 3. So we have y equals negative 2x minus 3. Okay, so we rewrote it from standard form to slope-intercept form. Now let's look at 4x minus 8y equals negative 56. Same thing, I need to get y by itself. So let's get rid of the x variable term that's on the left side. So we'll subtract it away. 4x minus 4x will cancel. That will leave me with negative 8y equals negative 4x minus 56. Okay, again, these are not like terms, so I can't put them together, so I'd have to leave them as separate terms. Okay, I'm going to divide everything by negative 8. Those will cancel, leave me with y equals negative 4 over negative 8 is a positive 1/2. So we have 1/2 x. Negative 56 over negative 8 is a positive 7. So we have 1/2 x plus 7. Okay, we need to compare their slopes. So the slope of the first line is negative 2. The slope of the second line is 1/2. Now they're not the same, so these are not parallel. We knew that already because we found an intersecting point. And if they're parallel, they don't have an intersecting point. Are they perpendicular? Okay, so to be perpendicular, they have to have opposite signs. Here we have a positive and here we have a negative, so that criterion is checked. Are they reciprocals? Is 2 the reciprocal of 1/2? Yeah, it is, really. If you think about it, 2 is the same thing as 2 over 1, right? And that is the reciprocal of 1 over 2. So, yeah, they are opposite signs and they are perpendicular. Or they are reciprocals, so therefore they are perpendicular lines. Okay, recap. Opposite signs, we have a negative and a positive, and they're reciprocals. 1/2, 2 over 1. Therefore, we have perpendicular lines.